When we studied sound waves, you remember there were certain frequencies that humans can hear, but there are some higher frequencies that other animals can detect. Dog whistles have a higher frequency than human ears can detect. It works for dogs. With echolocation, whales, bats, they can detect higher frequencies than humans can hear. With light waves, there's an entire spectrum of wavelengths, but there's just a small amount of wavelengths that our eyes can detect. The small amount of wavelengths that our eyes can detect, that's the visible spectrum, represented here with Roy G. Biv, red, orange, yellow, green, blue, maybe indigo if it exists, and violet. These are wavelengths of different lengths. Okay, so red is the longest wavelength that we can detect. And as we go down this Roy G. Biv spectrum, this violet would be the fastest frequency and the shortest wavelengths that our eyes can detect. We can see colors because they are bounced back to us. So these wavelengths that we don't see when we're looking at a green shirt, all the other wavelengths are absorbed into the material, and what bounces back, what is reflected back is green. That's what we see. That's why we see color. That wavelength is bounced back to our eyes. But there are other light waves that we cannot detect. Either the wavelengths are too big, like radio waves, or the frequency is too fast, the wavelengths are too small, things like gamma rays, X-rays. We can't see radio waves, but we know they exist. We use radio waves in tools like radios. And X-rays, we cannot see an X-ray, but we can see an image that an X-ray will produce when we put it into a tool that we also call an X-ray machine, so that the ray is captured and turned into a visual that we can see.